Okay, I'm not exactly sure where that left off, so let's just quickly talk through our list again. So my x initial is at 0 because I'm starting at the origin. X final is what I'm solving for because it said how far. Velocity initial is 0 meters per second because I start at rest. Velocity final is 25 meters per second because we want to know how far we've gone when it is traveling at 25 meters per second. A unit of velocity. My acceleration is 3.5 meters per second squared. Got that right there. Time initial is 0. I do not know time final. So now I've drawn a picture, I've established an origin, I've made a list of knowns and unknowns. Now I need to pick an equation where I know everything except for my unknown, which is x final. I do not have time final. And so I can't include an equation that has time final. This equation won't work because it's a constant or average velocity, and my velocity changes. This one has time, so that's not going to work. Average velocity or constant velocity, so I need to use a different equation. That one has time, so I can't use that one. This one should work. I know velocity final and initial. I know my acceleration, and then delta x would be final minus initial, and that contains my unknown. I can't use this one because it has time, and I can't use that one because it has time. So this must be the equation that I'm going to use. So velocity final squared is going to equal velocity initial squared plus 2 times by acceleration times by delta t, which is t final minus t initial. Okay, so let me double check. I know this, I know this, I know that, or sorry, did I put t? It is a delta x, not a delta t, because I don't have time final. So that would be an x final minus an x initial. I'm solving for that, and I know this. So I know everything except for my unknown. Now let's look at which ones of these are zeros. X initial is 0, velocity initial is 0, time initial is 0, not included. So I will rewrite this equation now, dropping those 0 components. So velocity final squared will equal 2 times by acceleration times by x final. And I'll solve for my unknown. Right now it's multiplied by 2 in acceleration, so I'll divide both sides by 2a so that it'll cancel here. So what I'm left with is x final equals velocity final squared divided by 2 multiplied by acceleration. Okay, I rearranged my equation so a unit analysis is required, as well as my final numerical analysis, my final answer, right? So let's start with our units. I'm taking a velocity and I'm going to square it. So my velocities are meters per second. That's going to be squared. And I'm going to divide that by acceleration. Because 2 is unitless, acceleration is meters per second squared. Now since this whole unit is squared, that square can distribute. This is the same as meters squared per second squared divided by meters per second squared, or meters squared per second squared multiplied by the reciprocal s squared over meters. So that will cancel, and then this will cancel with one of those. So what I'm left with is meters over 1, or meters, which works out because I'm solving for an x final. So this is a great analysis, a way to confirm that I very likely rearranged my equation correctly. So now that I've done a numerical analysis, a unit analysis, now I'll do a numerical analysis. Since I've made my list of knowns and unknowns, I don't need to rewrite all of them in the equation because I've already communicated what each of these values numerically represents. So I'll plug that in my calculator. Velocity final, which was 25 meters per second, divided by 2 multiplied by the acceleration, which was 3.5. Okay, 2 sig figs, 2 sig figs. So my final answer will be 2 sig figs, so that'll go 89 meters. Okay, our last problem. A bike rider pedals with constant acceleration to reach a velocity of 7.5 meters per second over a time of 4.5 seconds. During the period of acceleration, the bike displacement is 19 meters. What is the initial velocity? That's what I'm solving for. Okay, let's draw a picture, establish an origin, make a list of knowns and unknowns. So we have our bicycle, and we're going to head this direction in a positive direction. We'll say that where we start will be our origin. And then I'll make my list of knowns and unknowns. I'm going to use the same list to help me identify and make sure I don't forget anything. So x initial, x final, velocity initial, velocity final, acceleration, time initial, time final. Okay? It's important that we think through when we make this list, because what if I didn't think about x initial and then I'm trying to pick an equation and I go, wait, there's not one that I can use because I don't know x initial. But you do. You've drawn a picture and we establish an origin, and then that indicates to us, oh, I am starting at 0 meters away from my origin. Okay. Well, x final, let's see if we have that info. Oh, the bike's displacement is 19 meters, so when it ends, it's 19 meters away from its origin. Velocity initial. That's what we're looking for. What is the initial velocity of the bike? Velocity final is 7.5 meters per second. We know this is a constant acceleration, but we don't know what that acceleration is. Time initial would be 0 seconds, and time final would be 4.5 seconds. Okay. I've drawn a picture, established an origin, made a list of knowns and unknowns, so now I'm going to choose my equation. I need to choose an equation where I know everything except for my unknown. So, velocity average, no, my velocities are changing, I can't use that one. Acceleration, oh, I don't have acceleration, so I can't use that equation. Average velocity again, so this one's not going to work. Final initial, oh no, acceleration. I don't have acceleration. I don't have acceleration. I don't have acceleration. Okay, I know x final and x initial. I know my velocity final is 19. I'm solving for my velocity initial. And I know that my time final is 4.5 seconds. So I know everything here except for what I'm solving for. So I'm going to choose that equation. Delta means final minus initial. So x final minus x initial will equal 1/2 velocity final plus velocity initial multiplied by time. And when time is alone, we can assume that we're talking about time final. All right, let's double check. Yes, I know these. I'm solving for that. I know what this is and I know what this is. So I know everything except for what I'm solving for. So that means that this is a great equation to use. Let's identify zeros. X initial is 0. That's my only one. Time initial, but that's not part of this equation. Okay, so x final will equal 1/2 velocity final plus velocity initial multiplied by time final. Now, last time I solve for time final from this equation, but this one's different. I'm solving for velocity initial. So I need to isolate this. So since this is in parentheses, let's get rid of the other items first. 1/2 and t final, they are multiplied to these components in our parentheses. So let's divide both sides by 1/2 t final. And again, the reason why this works is because these are multiplied by my unknown, and so since it's on top and bottom, that can cancel. Dividing by 1/2, just like I was showing you up here, dividing by 1/2 is the same as multiplying by 2. So if we wanted to, we could rewrite that as 2 multiplied by x final divided by t final. So you can do this, or you can leave it as 1/2 below. Either way is fine. And that equals not just velocity initial, velocity final plus velocity initial. Now I want to isolate velocity initial, and it's added to velocity final, so I'll subtract velocity final to both sides of my equation. So I will have 2x final divided by time final minus velocity final equals velocity initial. I've rearranged my equation to solve for my unknown, and since I rearrange, I'm required to do a unit analysis, and then I'll end with my numerical analysis. Unit-wise, 2 is unitless, x is meters, divided by time, which is seconds. I'm going to subtract that from velocity final, which is meters per second. Well, meters per second minus meters per second just gives us units of meters per second. And that's good because this is a velocity. And I ended with units of a velocity, so likely I rearranged this equation correctly. So my final step here is a numerical analysis. I've already declared what each of those items represent numerically, so I don't need to rewrite it if I don't want to. I can just plug it into my calculator. Okay. 2 multiplied by x final, which was 19 meters, divided by time final, which was 4.5 seconds. So this whole thing is going to be subtracted from velocity final, which was 7.5. Okay, now 2 sig figs, 2 sig figs, 2 sig figs, so I'll go with 2 sig figs, 0.94, and this is meters per second. All right, guys. That's your best approach to word problems and using those motion equations. If you have any questions at all about this, please feel free to email me or to sign up for a study session.